Today we discuss what is an algorithm, what is an algorithm, what are the characteristics, what are the characteristics of an algorithm, what are the characteristics of an algorithm, how to calculate the space and time complexity of an algorithm. So today's topic is what is an algorithm? What are the characteristics of an algorithm? How to calculate the space and time complexity of an algorithm? First of all, we'll discuss what is an algorithm. An algorithm is a finite set of instructions to accomplish a task. What is an algorithm? An algorithm is a finite set of instructions to accomplish a task. To accomplish a task. So to accomplish a particular task, for example, you want to perform addition of 5 numbers. So to perform this addition, we use some set of instructions. Those set of instructions we called as an algorithm. Suppose I want to calculate simple interest. To find the simple interest, we use some set of instructions. Those set of instructions we called as an algorithm. An algorithm is a finite set of instructions. It is a finite set of instructions to accomplish a particular task. So in order to perform any task, we use a particular algorithm. The characteristics of an algorithm is the characteristics of an algorithm is, what are the characteristics? One is called as input. The first characteristic is input. What is input? An algorithm has one or more inputs. So input means the set of state 0 or more. So say, input means the values which are given are called as input. An algorithm has 0 or more inputs supplied. An algorithm has zero or more inputs supplied to perform task. This first, an algorithm has 0 or more inputs. So inputs supplied, 0 or more inputs supplied to perform a task. So to perform a particular task, we need to supply some inputs are 0 or more. For example, suppose we want to calculate simple interest, we need to supply principal, time and rate of interest. When we supply these three inputs, then only we can calculate the simple interest. Similarly, for example, to perform largest of three numbers. So to perform largest of three numbers, it is necessary to supply three numbers. So like this, so to perform any task, so it is necessary to supply zero or more inputs. So you have to say zero or more, depends on the problem. For example, I want to print the name, my name. Suppose then no need to supply the input. So depends on the input, we get depends on the problem, we can supply zero or more inputs. This is the first characteristic required. Second one, output. An algorithm will produce at least one output. The algorithm will produce at least one output. So all algorithms. So if you take an algorithm, the algorithm will produce at least one output. It must be produce at least one. So one output must produce jaruguta untadi. That's one. Next, definiteness. 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 What is definiteness? All the instructions in the algorithm must be very clear and so unambiguous. All the instructions in the algorithm is clear and unambiguous. All the instructions. That means whenever we are writing the instruction, that instruction must be very clear. So there is no ambiguity. So that's what we are called. That's what we called as definiteness. So definiteness means whatever the instruction we are writing, whatever the statement you are writing, that statement must be very clear. It should be very clear. There is no ambiguity. So that's we called as definiteness. Fourth one, finiteness. Finiteness. What is finite? All the algorithms must be terminated after finite number of steps. All the algorithms must be terminated after finite number of steps. That's we called as finiteness. Next one is effectiveness. Effectiveness. So all the instructions must carry out a function. So all the instructions are feasible. So we call it as feasible. All the instructions are feasible. All the instructions are feasible. It is enough to that each operation must be definite. So each instruction must be basic carried out in the principle by Pearson principles. So these are the characteristics. So what is character? What is an algorithm? What are the characteristics? What is an algorithm? An algorithm is a finite set of instructions to perform a specific task or to accomplish a task. That means to perform any task or to accomplish a task, we use some set of instructions. Those set of instructions we called as an algorithm. An algorithm has some finite number of characteristics. So what are the characteristics? One character is an algorithm has zero or more inputs applied to perform a task. So first one is input. So an algorithm has zero or more quantity of input supplied to perform a task. So to perform any task, it is necessary to supply zero or more. Depends on the problem, we can supply the inputs. So for example, I want to print my name, so no need to supply input. Suppose I want to calculate simple interest, it is necessary to supply three inputs: principal, time and rate of interest. Similarly, to calculate the to convert temperature, the area of a circle, so next it is necessary to supply the radius. So suppose we want to calculate the area of a rectangle. So to calculate the area of a rectangle, it is necessary to supply length and breadth. So like this, it is necessary to supply some set of inputs, zero or more inputs. That's we call as input. Output. An algorithm will produce at least of one output. So it produce at least of one output. That's we called as output. Definiteness. Each instruction in the algorithm must be very clear and there is no ambiguity. So all the instructions, whenever we are writing an algorithm, the instructions in the algorithm must be very clear. There is no ambiguity. So there is no confusion. So ambiguity. Finiteness. All the algorithm must be terminated after a finite number of steps. So it must be terminated. Effectiveness. All the instructions are feasible and effective. That means we can perform operations only by pen and pencil. We perform carried out. So we can perform effective. It's effective means so when we performing operations, so by a pen and pencil we can perform the tasks very clearly. So it's a very clear enough to carry out the principle of person by only paper and pencil. For example, I will go for an example how to write an algorithm. For example, so generally we write in our algorithms, we write first of all we write algorithm. No need to specify written type. For example, first we write algorithm. For each algorithm, we write the keyword algorithm. Suppose I want to calculate the maximum of n numbers. So maximum. Suppose I want to calculate maximum for n numbers. Maximum. What is the input? This is the input. Suppose 20. No need. Actually, data type is not necessary. So you have to just write them. Then algorithm. So I want to calculate the maximum of n numbers. So how to find the maximum of n numbers? So we assign first number as a max. Max equal to what the first number? Max of max int this we write one variable a of 0. Max equal to a of 0. There is no case sensitive. Algorithm is not a case sensitive. You have to write either small or capital letters, no problem. So max equal to a of 0. So then we go for I equal to 1, I less than n, I plus plus. If a of I greater than max, max equal to or return max. This is the algorithm to find the largest of n numbers. Suppose I want to find the largest of n numbers, so we use the statement like this. So this is the way to find the maximum of n numbers. So this is an algorithm. So like this we can. Suppose I want to calculate simple interest. Suppose algorithm. Simple interest. So what are the parameters required? Principal. Int time. Int rate of interest. Principal, time and rate of interest, ROI I will call. So what are the variables required? What are the inputs supplied? Principal, you need to supply principal, time, and rate of interest. Then we can calculate interest. So what is the how to calculate interest? Principal into time into rate of interest by 100. This is the way to calculate. Finally, we return interest. So this is the algorithm. In this way we can write the algorithms. If you check it, each instruction is very clear. So there is no ambiguity. So very clear. There must have a finite set of instructions and very clear all the instructions. It is very effective because so whenever we are performing we can carry the result by using pen and pencil. That's we called as effectiveness. So inputs, we are supplying the inputs to in this program we are supplying 3 inputs. In this program we are supplying 2 inputs. So input and output is in this program, the output is maximum. In this program the output is interest. So like this we can perform this. One or more. Suppose I want to perform largest sort the numbers, for example. Suppose we want to perform bubble sort. So bubble sort, this is the one. Actually, no need to explicit declaration of variables, just bubble sort. So actually, a bubble sort will require n-1 passes to sort n numbers for I equal to 0, I less than n-1, I plus plus. For j equal to 0, j less than n-1, j plus plus. If a of j is greater than a of j plus 1, then we can interchange temp equal to a of j equal to a of j plus 1, a of j plus 1 equal to temp. No explicit declaration of variables. In algorithm, there is no explicit declaration of variables. So a of j plus 1 equal to, it's not a case sensitive. Algorithm is not a case sensitive. Algorithm is not a case sensitive. There is no explicit declaration of variables. We can write small and caps, no problem. So this is the way to write the program. So this is the program for this is the algorithm to find the largest of bubble sort to sort the numbers. So like this we can write the algorithm. So this is called as algorithm. So these are the different examples. So this one example. So this one example. One is one example. Algorithm to find maximum n numbers. So this is the algorithm. This is another example. Algorithm to calculate simple interest. This is another algorithm to find sort the numbers using bubble sort. This is the way. So this is the like this we can write the algorithms. Okay. So this is about algorithm. We already discussed the characteristics. Based on those characteristics we are written. Then how to calculate the space complexity, how to calculate the time complexity. I already told the time complexity for bubble sort is order of n square. So how we can calculate the time complexity of order n square? So what is the process? So there is a technique how to calculation of programming, calculation of time complexity. So first we will go for space complexity. What is space complexity? How to calculate the space complexity of an algorithm? So what is a space complexity? A space complexity will defines the amount of storage required for an algorithm that we call as a space complexity. A space complexity will defines the amount of storage required. So amount of memory needs to run the completion. So to run the to run to so that's need to run to completion. That's we call as space complexity. So space complexity means it defines the amount of storage required to run to complete. Or we say that the amount of storage required so to run the program, that's we called as so in other words we can also say that the amount of storage required run the program, run the algorithm is called as space complexity. So what is a space complexity? So what is a space complexity? A space complexity will defines the amount of storage required, the amount of storage whatever, the amount of storage required to run the program, that's we called as space complexity. So actually space complexity has two components. One is called as fixed space requirement and another is called as variable space requirement. A space complexity has two components. They are, first one is fixed space requirement, fixed space requirements. Second is called as variable space requirements. So it has two components. One is called as fixed space requirements, another is called as variable space requirements. So what is fixed space requirements? So fixed space requirements, that means the amount of fixed storage requires to run the program. However, it does not depend on the program input and output. So that means the program, the algorithm, the code for this program, the fixed storage required to run the program. However, it does not depend on the number of inputs and outputs. So generally it includes instruction space. That means space need to run the program. So space for variables, fixed structure variables. That's we called as constants. So fixed space requirements will define what is fixed space requirements. So fixed space requirements includes includes the instruction space, that means the space need to store the code. That means what is instruction space? The space required to store the code. That's we will call it the instruction space. Space for variables, variables, space for fixed size structure variables, and space for constants. It does not depends on program input and output. That's we called as a fixed space requirement. A fixed space requirements will defines. It includes. So that means in fixed space requirements we specify the amount of space required for. That means how much space required for the statements. For each statement, how much space requirements. For variables, what is the storage requirements? For constants, what is the storage requirements? For structure variables, what is storage requirements? Like this, so we can define fixed variable. That's we called as fixed space requirements. And another is called as second one is variable. Variable space requirements. So this consists of space needed by the structure variables whose size depends on an instance. It defines the space required by the variables whose size depends on a particular instance. Whose size depends on a particular instance. For example, if I written a program in recursion, suppose I supplied input as a n. So if n value is 10, then the stack is 10, then the size of the stack is 10. If the n value is 20, then the size of the stack is 20. If the n value is 100, the size of the stack is 100. That means the space, so the space is variable. So where it will be varied, where it become depends on the supply. So that's we called as a variable space. So that means for an instance, depends on the instance, the storage will be allocated. That will called as a instance. So that means, for example, when it requires an additional space, it requires an additional space when the problem is solved by using recursion. So when you solve the problem by using recursion, the space is different. So that's we called as a variable space. So that's we called a variable space. So that means variable space depends on the problem. So when we solve the problem by using recursion, its space is required. Additional space is required because whenever we are using recursion, so we call the stacks actually. So that's we requires additional space. So that's the way. So calculation. So finally, the space complexity, S of p, here p the program, S of p equal to c plus S of p p. Fine. here. So C is space for fixed space requirement, fixed requirements, and S of P of phi is variable space requirement. This we call as space complexity. What is space complexity? So space complexity defines the amount of storage required. So what is the storage required? The amount of storage required to run to completion, or the amount of storage required to run the algorithm is called as space complexity. Space complexity has two components. One is called as fixed space requirements, another is called as variable space requirements. Fixed space, what a fixed space requirement? A fixed space requirements indicates the instruction space. That means what is the storage required for the instruction. That's called as instruction space. The space required for the variables. The space required for the structure variables. The space required for the constants. That's called as fixed space requirements. So variable space, when the problem is solved in recursion, we need some additional storage. So that's we called as variable space requirements. So it depends on the problem. So the problem is solved in different ways. When we solve the problem by using recursion, so additionally it requires some space, because whenever we are using recursion, so it automatically creates a stack. That's why it needs some additional space. That additional space we called as a variable space. It defines the space required by the variables whose size depends on a particular instance. That is, it requires an additional space when the problem is solved by using recursion. So that's we called as recursion. So finally the space complexity for an algorithm for a problem is S of p equal to C plus SP of I, where here C is the space requirement, fixed space requirement, S of I is the variable space requirement. So like this we calculate the space complexity. Actually, suppose if I take a program, if I take any one program, so it depends. So additional, so depends on problem, we can write it. For example, so if I take one problem, so let's go for time complexity. What is time complexity? How to calculate a time complexity? A time complexity of, so time complexity is sum of the compile time plus and its runtime. So time complexity. The time complexity is that means the amount of time required to complete the program execution is called as time complexity. The amount of time required to complete the program is called as time complexity. The time complexity is sum of compile time and execution time. The time complexity is sum of compile time and execution time. the sum of compile time and sum of execution time. So so this is about time complexity of a program. So how to calculate the time complexity? Suppose I want to calculate a time complexity. How to calculate the time complexity? So actually, to construct how to calculate the time complexity. So the procedure to calculate here, the procedure suppose how to calculate the time complexity. So what is the procedure we are using for a time complexity? So for that I will take one example and calculate the time complexity. Number of columns 4. Algorithm. Steps for execution. Frequency. Total. Suppose. So this is the suppose I will take an algorithm. So instead of writing this, I will write shortcut. Similarly, frequency also I will write it. Total. Suppose algorithm. For example, we already know maximum int of 20, comma int n. Then max equal to a of 0. This is the algorithm we have written already. Max equal to a of 0 for I equal to 1, I less than n, I plus plus. So I will go for not sum. So instead of right, we will go for sum actually. Sum of n. For I equal to 0, I less than n, I plus plus. Sum plus equal to a of I. Return sum. Suppose this is the algorithm, return sum. Suppose this is my algorithm. I want to suppose this is the algorithm. So what is steps for execution? SC indicates steps for execution. The steps for execution indicates whether the instruction is executable instruction or not. Actually, there are two types of instructions. Some instructions are executable instructions, some instructions are non-executable instructions. So declaration is executable. Declaration is. So if they are declarative instructions, that statements cannot be executed. So this is the declaration statement. The statement cannot be executed. So the step for execution of this is 0. So again we go for this. What is the frequency? It is not executed 0. So it is also not executed. So again we go for this. This is also not executed. So for example, so algorithm, sum of numbers in A of 20 is the statement. Actually, this is a declarative statement. So if it is a declarative statement, then the step for execution of this statement is 0. SE indicates so where steps for execution, whether the instruction is executable statement or not. Actually, the declarative statements and declarative statements are non-executable statements. That's way. So this is the declaration statement. For this is 0. The frequency, it is not executed means the frequency of this instruction is 0. Then the total is 0. Then you go for next line. 0. Then we go for begin. So actually this is also declarative statement. For declarative, this the time is 0. So this is also steps for execution is 0. So frequency, it is also not it's not executable statement. So the frequency is also 0. It is not executable statement. That's why then we go for sum equal to 0. So in sum equal to 0. This is executable statement. So this is executable statement means the steps for execution is 1. If 1 indicates it is executable statement, 0 indicates it is not executable statement. So it's executable statement. How many times the statement will be executed? Only one time. So this is the time. Time is how many times? This is only one time. Then the total space is also one time. Then for loop for I equal to 0, I less than n, I plus plus. This is the statement. So this is executable statement actually. So this executable statement, this is executable statement. So if it is executable statement, the sequence count is 1. Sequence count is 1. So then frequency, how many times this statement is executed? So if it is n, if the statement is for loop will be executed n plus 1 times. For example, if I write for statement for I equal to 1, I less than or equal to 5, I plus plus. Initially I equal to 1, test the condition I less than 5, yes. Again I equal to 2. So 2 less than or equal to 5, yes. Again I equal to 3, 3 less than or equal to 5, yes. I equal to 4, 4 less than or equal to 5, yes. Again I equal to 5, 5 less than or equal to 5, yes. Again I equal to 6, 6 less than 5, no. At that time only we can exit from the loop. So when we use the loop for n times, the looping statement will be executed n plus 1 times. This the frequency is n plus 1. Then the total is n plus 1 times. Then the total is 1. Then sum plus equal to sum equal to sum plus a of I. How many times this statement will be? This is also a executable statement. So this is a executable statement. Then the time complex is the sequence count is 1. So how many times this statement is executed? N times. N times, because for loop will be executed. First statement will be executed n times. The statements within the loop will be executed n times only. The for will be executed n plus 1. The statements within the loop will be executed n times. This is n. Finally, return sum. How many times this statement will be executed? This is also executable as a written statement. So written is a executable statement. Yes, it is also executable statement. So the time is 1 time. So this is 1. It's 1. So this is 1. 1. Finally, we have the end braces. So end brace is not executable statement. So this is steps for execution is 0, and how many times the statement is executed? 0 times. So it's a 0, and that total is also 0. When you add all these totals, when we add all the steps, then the time complexity is 2n plus 3. Time complexity equal to, so when you add all these statements, it becomes 2n plus 3. So that's why when we ignore the constants, then it is the time complexity is order of n. We say that. So exactly we say that order of n plus y, or exactly if we take for exactly, so it is 2n plus 3. So if we take for temporary, so like this. So when we ignore the constants, then it is n order of n. So this is the way to calculate the execution. This like this we can calculate. This is the process we are using to try to calculate the time complexity. For example, this is the algorithm. This is the algorithm. So here steps for execution indicates whether it is an executable statement or not. All declarative statements are non-executable statements. Non-executable statements, steps for execution is 0. For all executable statements, the steps for execution is 1. Frequency. So frequency means how many number of times the statement will be executed. Sometimes it will be executed one time, sometimes n plus 2 times, sometimes n plus 1 time, sometimes n times. That's we call as frequency. The frequency itself, it is a total. When we add all the total, then we will get the time complexity. This is the way to calculate the time complexity of a program. This is the way. Tomorrow I will explain one more example how to calculate the time complexity. So like this we will calculate the time complexity. So tomorrow I will clarify your doubts also. If there is any doubts, so I will clarify your doubts also. So if there is any doubts, so I will clarify your doubts tomorrow. So because so there is not enough time to clarify your doubts. So actually, again, it's necessary to explain one more example, time complexity. I will take 2 or 3 examples and how to calculate the time complexity. So then you can understand how to calculate the time complexity of an algorithm. So it's very necessary. So okay, tomorrow I will explain once again. I will explain how to calculate the time complexity. Okay, thank you very much.